I almost just accidentally hit the stop stream button because I thought it was switching my... It's okay, I didn't do that. Oh, I also just looked at this and it's 9 pages. They'll love that. They'll love that. It's not like I don't have like 20 pages of review to do for this final anyway. It's okay. It's okay. It's okay. It's okay. I'm normal. Bye. Yeah, I don't know. We're just gonna jump right in, I guess. So this is the last thing. This is the last thing, last topic in the sort of intro dynamics course. It's impulse and momentum of rigid bodies. So we did impulse and momentum particles, and now we have to do it for rigid bodies. I don't know if the solutions are posted for this, but if they are, then that would be great, because we can just kind of follow along and see if we have conceptually sort of the right ideas about stuff, which I think I do, because it's pretty much just particles. Particles plus acceleration. So basically like what we did for FMA, but for particles. So not particles. Don't listen to me. Oh, this is a problem that I did. Oh, it's so funny because my professor is doing like Zoom review sessions, and I'm like, oh, I need to go catch my professor's stream. I'm like, no, she's not streamer brained. +2s in the chat, everybody, for my Twitch professor, please. Not my Twitch, fuck. My non-Twitch professor. Anyway. God, 14 problem sets. That's a lot. That means that we did, on average, more than 1 problem set per week, which I think is a lot. I don't know if I would condone that. I feel like there's gotta be a way to make it even. Probably not, though. Because you just have too many topics. Alright, let's see. Okay, oh god, so this is a rotation versus translation type problem. Slender bar A is rigidly connected to a massless rod and 2 massless cords. It's negligible. The vertical thickness is negligible compared to L, so basically it's like a line. Like a point, but like 2 points connected. If it strikes A, the bullet strikes A with speed VO and becomes embedded in it. That's one of those days, okay. How will the speeds at the center of gravity compare for the 2 cases? Okay, so in case 1, we have impure rotation. So I mean, just think about it in terms of work and energy. I mean, you can think about it in terms of whatever. So we're gonna have an MV2 and a what is it? I bar omega 2. Can't see that at all. So we're gonna have an I bar omega 2 there. And then in terms of this one, it's not rotating, so we're just gonna have an MV2. So it's asking the speeds of the center of gravity, not the actually, well, okay. So the speed of the center of gravity is going to be, for MV2, it's going to be this way. And then for this one, it's going to be this way, right? Oh, I moved it. It's going to be this way. So what I was thinking in my mind just now is I bar omega 2. Oh, never mind, I lied. This is I bar V2 over R. Right, so we're gonna have a slightly larger... Is that... Wait a second. Which one would be bigger though? I'm thinking. In this case, that means that we would have M times V2, or sorry, V2 times M plus I bar omega 2, which means that whatever this would be on this side, sorry, not omega 2, I bar over R, versus V2 equals like X divided by just M. Okay, so this one's going to be, yeah, this one is going to be smaller because we have more stuff that we're dividing on the other side. I was thinking about it, I was like, 1.5V, we should be adding sort of like we should be taking away energy, but like, what's the math there? But yeah, that makes sense. So this is like x equal over x. It's a little sloppy. It's a good word. I like the word sloppy. I think it's a funny word. Also, soggy is a good word. Anyway, case 2 will be larger. Metal pipe. Thank you. This is okay. This is not a metal pipe, but it could be a metal pipe. You know, there was a problem I had that actually like screwed me over so hard. It was a metal pipe. It was a pipe, and it looked like this, and it was yellow. This is for my materials class, and it was asking me to point right here on this metal pipe, and had a force here, and a force here, and a force here, and a force here. 4 forces. There was one moment from this one. There was one moment from this one. There was 2 moments from this one. And there was 1 moment from this one. And like my brain just like stopped. I forgot that it was a pipe like this too. And I forgot like what Q. I was confusing what Q and okay, you guys like don't know because we haven't done any combined loading problems. Oh no, we did talk about this. Like when you do the stress states, like we did when we had like a cross section of a bar. Q is, I don't know what Q is. I don't know what the actual thing is, but it's like some flow thing. It's not that. It's actually, I do know what it is. It's the first moment of area instead of the second moment of area. That means nothing to anybody. It's like a thing that doesn't exist. Don't worry about it. But yeah, I was confusing it with I-bar, which is totally different, which also sounds like insane because I'm just saying letters out loud and saying that they're different. But that is the life of a wizard. Anyway. So yeah, metal pipe, not my friend the other day, unfortunately. But now it's my friend. I love metal pipes. Okay. I don't think I actually have to turn this in. I don't think I get any extra credit for turning this in, so I don't have to like do anything, which is great. Oh god, okay. Sorry, I just saw this and I was like, it's gonna ask me about the center of gravity, and I don't like that. Now we're chilling. A 1 meter long, uniform, slender bar AB has an angular velocity of 12 radians per second. Its center of gravity has a velocity of 2 meters per second. 2 meters per second. About which point is the angular momentum of A smallest at this instant? Okay. HP, which is a crazy... I don't know why they named angular momentum H. I feel like when I learned angular momentum, I learned for linear momentum, I learned P. We called it P, and for angular momentum, I think we called it L, like a big L. Which is the case for when you're doing angular momentum, you have to take a lot of L's. Okay, that was a bad joke. I don't know why it's H. We also didn't call linear momentum anything. We literally only called linear momentum MV, which is boring. Why don't we give it some fun thing? Why don't we call it like a big heart? That's what I think it should be. I would, if I had the guts, I would do a problem on the final with, instead of any variable names, I would only use like stars and hearts and stuff. I don't have the guts for that though. I would get a 0. I wouldn't get a 0, actually. This is a very nice final, I think. I'm way more worried about my mechanics and materials. He's like, so we've had a lot of problems with cheating. So you have to, you take every piece of paper and you have to tear it off into a different pile, and you have to sort them all in different piles. I was like, what the fuck, dude? Like, he's like, each one of your tests are numbered, so you're gonna put it in different piles, and you're not gonna have your name on any of them. But if we're missing one of your problems, then you're gonna get a 0 on the final. I'm like, what the fuck? If you're missing one, you're gonna get a 0? What if you like lose it? What if somebody loses it? What if somebody steals mine and then I get a 0 on the final? How do they know? It's so scary. He's like, somebody was like, are they gonna grade it the same as he graded the quiz? He's like, no, we're not gonna be as nice as we were on the quiz. And I was like, dude, you took off, like, you gave people a 75% if they got like one plugged in value wrong. How are you gonna be less nice than that? Like, bro. I mean, they have to grade 450 of them, but like, goddamn, dude. Like, at what point just say, I'm sorry, I'm gonna put this into a computer and grade it, because like that seems like it might be nicer at that point. Anyway, we're trying to find angular momentum. What is angular momentum? What's the definition? It's like I bar omega, probably. I don't like, cause you know. Oh, you know, just me and my angular momentum chilling, because we're cool like that. Yeah. Yeah. And there's moments, but like, yeah, we don't need a moment. Don't worry about it. There's no moments. Oh wait, yes there is. This is the depressed noise, sorry. Okay, which is the one, wait, where is it smallest? Okay, it's not the same about all points. It would be smallest at... Oh, this is fascinating. Would it not be the same at P2 and P3? Does it have to do with the... it has to do with the adding things. I see. Okay. Sorry, big brain. Alright, let me draw some stuff. So we know it's not going to be the ends. The ends are going to be big because they're going to give us a big radius. So we just care about these two dudes here. So we have this, and we have this. We want to make it the smallest, so we have to make sure that this doesn't create a moment this way. So this one, it creates a moment for the bottom, this creates a moment this way, and that adds to this. For this one, it creates a moment this way, and it is smaller. So we are going to do P2. Big brain. Okay, that was a very easy question. That should not have wasted so much time. Okay. I don't know why I'm like so worried about this final, because I went to a review. I was saying like these Zoom reviews. I went to a review and I did the problem in like 15 minutes, and it took everybody else like way longer to do it. And not that like I'm saying other people are bad, but it took everybody else like way longer. And when she was going over it, she was like, okay, well, you do this and this and this and this and this. And she was taking all this time to go over it. And I was like, I got all this right. Like, and I thought it was really easy. And I was like, are they gonna be this like easy on the final? And she was like, I wouldn't say it's easy. And I was like, oh, okay, well, that's good news for me, because I kind of thought it was easy. Because I mean, like so many of these problems have like tricks. They have like tricks to get you. Like, you have to like see that stuff is a certain way, and if you don't see that it's a certain way, you're screwed because you didn't see it and you got tricked. But this one was just like relating 2 points, and if you could like relate the 2 points and then do F equals MA, you were fine. And I was like, is this beautiful world the world that we live in, where I might not freak the fuck out? And she was like, okay, here's a hard problem. And it was this problem that I showed you guys. This one. She's like, this is a hard problem. And I was like, the only thing that was hard about it was I couldn't figure out the geometry. I was drawing so many lines everywhere. I was like, I don't know any distances. I don't know any angles. I don't know who I am. I don't know where I am. And I couldn't figure out the distances, and that was the only hard part of the whole problem. Like, this is not like an off-balance centroid. She gave us like 20 of these problems to do. I think she's just a good teacher. I haven't written her a review yet. I have to give her a good review. But it's hard because like, it's a really important class, and so I know I'm gonna write a lot even though it's gonna be a good review. And I just like didn't have the time for it. Anyway. Okay. Sorry. Let's go. Let's do this. A disc of weight 5 pounds, so probably not just some FMA stuff, is at rest when placed in contact with a belt which moves at a constant speed equals 50 feet per second. Knowing that MUSIB... Okay, we actually have done a problem like this with... Will you ever do something normal like simple math? Actually do biology. I'm not a big bio guy. But simple math, I mean, I do want to make stuff that's like... Well, first off, I don't think I've really talked about it too much, but I want to do, like, labs, or some of them are maybe not really called labs, but I think of them as sort of like experiences or like explorations, which are just like playing around with concepts and not really like there's no like real like like there's no force that's like pushing you to have to learn something. Like it's not like you have to you know, do a test on it or something, but so those will all be very like relaxed and hopefully kind of fun. But simple math, I mean, I want to do like also sort of some introductory like for trig specifically, I want to do like a video on what trig is useful for engineering. But simple math, I mean, probably not. Like, I guess it depends on what you define as simple too, because like how do I like a lot of like this, for example, is not super hard math depending on how you do it. Like it's like multiplication and addition and stuff, right? Like it's algebra. But setting it up is obviously like the hard part. I don't know if that like kind of answers. So the answer is like no, but I will do stuff that doesn't have any math in it. For sure. When I just don't have the time to. Honestly, a lot of it is trying to figure out how I would be able to do that in a way that isn't like insanely time consuming for me. Because I would like to do it in VR chat, but I don't know how hard it would be to do some of the things that I want to do. Like, I don't know if I would have to code like so much. Like, I can code, I don't mind coding, but if, you know, if there's an easier way of me being able to do it, you know, that would be great. Okay, so there's no impulse here. We just have a change in momentum, so initially it's gonna have, I guess, 0? I guess we might want to do that. I don't really need to draw the belt because it's always constant. This is mvd1, this is omega equals 0. And the second one, we're going to conserve momentum. There's no, not getting punched or anything. It's going to rotate this way. So I bar omega. I guess I could call omega 2, but it'll just be I bar omega. And then, see, the thing is, like, I don't think we have, it's not going to move. Like, so it's not going to have a mass about the, like, it's not going to have a velocity about the center of mass. Which is kind of, I don't know if that's, I feel like this is wrong, is the thing. Because we need something. We need, it can't just, like, you can't just do this. You can't just do nothing. So maybe we say it starts at 1 and then goes to a constant angular velocity. But like, but it's the time required. That's why we can't do forces. Oh, bot message. Here, wait. Me when my Twitch chat tools are not out. How do I turn these on? Nope, that's not it. Show mod icons. Wait, Umbra's a mod. What? There we go. It's okay. Don't worry about it. I missed the ping? Oh, it's okay, I like just started. Oh, it's been 20 minutes, god damn it. Me yapping. I don't know how it's, okay. I'm trying to think about the states that we might have. Because it can't be 0, it's gonna have to be like... It feels like it's an FMA thing, or maybe... Are they trying to say that like the impulse is the whole ass time that it's speeding up? Because that would suck is the thing. Just started, it's fine. 3. Thank you. Oh, there, probably. I thought you just said 3. Maybe it's 0 and then we say forces. Let's try that. So omega equals 0, 1 equals 0. There we go. mg. And then we have a normal force. And then if we want to rotate around the right way, it's going to be pushing this way. Right, because the friction is actually traction in this case. It is pushing it the right way. I bar alpha. Nope, I bar omega 2 is going this way. And then I guess we also still don't have any MV. But see, this is sort of unfortunate because if geometry has taught me anything, it's pi seconds. Oh, I wish. Oh, I wish. Okay, so constant angular velocity means that we don't have any alpha. Does that help us at all? Nope, because it's impulse and momentum. Okay, which one of these are impulsive? I guess none of them are impulsive. I mean, they just happen over time. So this one happens over time. I like how I said none of them are impulsive and yet it happens over time, which kind of implies that it's impulsive. What I mean is, like, it's not impulsive as in it's not spiking. Like, this would be a normal impulse force, and then our friction force is like that. It's just, you know. You're given the size of the circle, the speed of the belt, the friction between them, and from that you get how long until the circle stops speeding up? Yeah, exactly. Yeah, so we're also given a weight, which is important. And we're given the speed of the, speed of the belt, yeah. Math. Yeah, a lot of it is just force. It's just forces. If you haven't taken a physics course, it's probably, like, a little confusing, but, like, essentially we have a couple different types of forces that exist in the world, right? Like, you can have, like, a gravitational force, you can have, a normal force, which is this thing that stops stuff from falling through other stuff. So like when you put your hand on a table, right, it doesn't go through the table. That's a normal force stopping you. You can have frictional forces. That's the FF right down the bottom here. In this case, because the belt is rough and it's sliding past it, it's going to pull the circle in the same direction as the belt is moving. And in this case, the circle, the disc is constrained, so the disc won't, like, if it wasn't constrained, it would start moving to the right and also, like, spinning. But since it's constrained, it's just going to spin because it can't move to the right. Alright, so we have a couple different things. We can do... I think this is, like, definitely wrong, the states I chose, because if I do this sum of the moments... Oh wait, no, okay. No, it's not definitely wrong, because if I do the sum of angular momentum, that would be like h, let's say about the centroid. So if we sum hg1 plus the integral of the moments about g dt equals all of our angular momentum after, so we're just saying that it's conserved if you count the forces. Well, I guess it's not conserved, it's just we're including all that stuff. We would get the friction being our... Oh, we can do this. This is gonna be 0, because we don't have an omega. And so... let's do this. Let's say hg2 equals I bar omega 2. We don't have anything else. It's literally just I bar omega 2. I don't really need to write that, actually. That's pretty straightforward. Okay, so we're gonna say the sum of the forces, sum of the moments. So this is gonna be this force here, so friction, times this distance that it's away from it. So that is, I'm just going to say times the radius. And that's going to be where if we move our hand, it's going to turn it in the positive direction. And that's going to equal I bar omega 2. So we can see in this case, our unknowns, we know I bar, we don't know omega 2, we want to know omega 2, but we don't know the friction either. But we can... Oh, there's a pin. There's a pin. Okay, wait. Which way is the pin? Yeah, I literally was like, it's gonna stop it from moving. Yeah, normal pin. Here we go. So if we want to get the frictional force, oh no, we're chilling. I just was like, how do we get the frictional? Friction. So friction. Okay, I'm gonna sum of moments in y equals may. We don't have any. It's not moving up or down. Okay. I mean, unless it was, but it's not. It's just rolling. So we're gonna have n minus mg equals 0. So n equals mg. Yes, I have to write that out every time. I'm sorry. Then we're gonna do ff. The definition is mu. Now in this case, this is mu sub s. Okay, they gave us a mu sub k, so it's a mu sub k. Mu sub k times n, and that's just our nice little friction definition. So we know that ff equals mu sub k times mg, and now that is all knowns. So we say mu sub k mgr equals I bar omega 2, and we can, our I bar I want to say is 2/5 mr squared. I don't know. They give me a table of these things on the test. Disk moment of inertia. 1/2 mr squared. Where's my 2/5 coming from? Oh, a sphere. I'm thinking of a sphere. It's not a sphere, it's a disk. 1/2 mr squared. Okay. Alright. So we have... I mean, I really don't need to do it like this at this point. Mr squared times omega 2, but I can cancel out some variables, why don't we? Equals 2 mu sub k g. Look at that. So it doesn't depend on the mass at all. It only depends on the gravity and the... Well, okay, this is neglecting like air resistance and stuff, but it only depends on the coefficient of friction between the two and gravity, which is pretty cool. We are in feet. Wait, it wants the time. Ooh, I didn't think about that. Wait a second. dt. Oh, also, wait, what would it be? Wait, okay, wait, it moves at a constant speed, v equals 50. Never mind, we know that, don't look at me. Don't solve for that, solve for t. You and I don't remember what we're solving for. POV. I just get too excited and then I, 1/2 times 50 divided by 0.2 times 9. 32.2. American system, sorry. Using calculus, I can determine that if I invest a 0.375 my net worth on some crypto or whatever, I will exponentially gain money. I wonder why nobody else has thought of this. I say, sitting in 0 pounds after failing the stock market and figuring out why nobody does math anymore. Okay, so... No, you, like... That... It's not always going to go up. Crypto's not always going to go up is the thing. Crypto can go down and you lose money. the same way that the stock market works. If the stock market only gave you money, I think everyone would invest in the stock market. Although that would be great. That would be, I mean, I support that. I think they should just give you money. The explanation accounts for losing. Wait. Oh, the equation. Oh, it's... Oh, I just whammed my head. Wait, where's my calculator? There we go. Sorry, I'm like bracing myself against the wall to grab my calculator. There is an equation in linear algebra, or I guess you could call it a model, maybe. It's called SVD, which stands for singular value decomposition. And I think maybe like 3 Blue 1 Brown probably has a video on it if you are interested in it. And it's this really cool algorithm that Drowning Friday that people use to like predict the stock market and stuff. Oh my gosh, wait, I turned off. Wait, what is it? Water. There we go. It is actually Friday. Wait, no, it's not Friday. It's Friday. Friday. It's Friday somewhere. Maybe. What was I looking for? I don't remember. Oh, I was looking at the answer. 3.8? Wait, how long has it been since we got an answer correct on the first try? It's been like never. I don't know if this has ever happened. This is so exciting. This is a monumentous day. This was like, this was like one of the easiest problems. But don't worry about this, a monumentous day, guys. It's been so long since I've gotten a W. Anytime I think about streaming and dynamics, I'm like, oh, I'm gonna get up there. I'm gonna get up there on Twitch and I'm gonna take L's all for a whole stream. This is beautiful. 3.88 seconds. Sniffles. Wait, this is she's just giving us the same problems that we had before, but now asking us to do them with impulse and momentum. Because I very vividly remembered this exact setup. I don't know if you guys did it on stream. Because I remember it, because it's a little annoying. Hear me out. There's a new meme coin, and you spend $20 on it, then you either lose a 20, then the reward outweighs the risk, therefore I infinitely earn money. Also 3.8 basically pi. I would okay, before you say 3.8 basically pi, let me tell you this. So in the machine shop, when you run like mills or like lathes, I did a lot of lathe stuff, you have to calculate like feeds and speeds for it, which are basically like saying like how fast you want the lathe to turn. Pi equals 4. Exactly. Pi equals 3, pi equals 4. Basically the same thing, you know? Yeah, go one way or another. You literally just go, oh well, it's close enough. It's close enough to 3. So, you know, 12 divided by 3 is 4. So just 4 diameter square. Pi equals 4 because of janky broken maths, true. Is equal to 3, but I mean, like, it's like saying E is 2. It's like close enough if you're doing, I don't know. One thing I would love to do a video on as well is like number sense, because I was always very bad at being able to like work with numbers and like break them up and like add stuff in my head until I started thinking about it a certain way. Wait, tau is 8? Last digit of pi is 8? I love the word tau. Tau's a great... Wait, tau is this, right? The issue with that is, like, we use this a lot in other things. And so, like we use that for torque, we use that for stress. Wait, no, tau is this. Wait, I think this is actually... It's, like, kind of goofy, right? I don't know. Anyway. Okay, no... Whoa. Know that after being released from rest, the system will change the speed of determine the centroidal radius of gyrate. Okay, at least they said that and not I-bar, because thank God, dude. Okay. Let's draw some pictures. So we'll start off with a big wheel. It's released from rest. They're being very kind to us. And then we're gonna add some stuff in here. Oh, you know. The stuff, the things. Ugh. Okay, they're not gonna score me on how well I can draw a circle, but I feel like as the resident industrial designer wannabe, I feel like I should draw some better circles, you know? I gotta represent. I say as I draw some bad circles. You know, they're better, they're more like, they have more character. I feel like they have more heart than like a poorly, like, you just gotta commit to drawing a circle. You can't really tell if it's bad or not. Okay, I don't know why I drew that one, so whatever. MG, there's a normal force here. That looks like it's going there. There we go. Do we tilt the axes? What do we think? The normal force is not going like that, but it's not going like that. It's going like this. We could tilt the axes. I would rather tilt the axes in favor of the normal force than the MG. I don't know. I should put a coordinate system on the other one. It contains the library of Babel, probably, right? That's like monkeys typing Hamlet. Okay, we are gonna have an MV, which we know the direction of, so this is MV2. And we're also gonna have a rotatey bit, which is I omega 2. And our I bar omega 2. Well, this is so chill of them, they like don't even really care about Wait, if we take the moments about G, we just have that garbage equals 0. Why would they let us do that? Oh, because the moments about G, there's a slight component there. Okay, I need to draw this a little bit bigger. This is really hard to see like this. Okay, we're gonna exaggerate. That's 1.5 inches. Don't worry about it. Don't worry about it. Okay, yay. You know that tweet that's like, don't worry about it. Don't worry about the economy. Or whatever. It's like, okay, yay, heart. It is DMs. I don't remember how it feels. Okay, here we go. So this is MG, and then this I'm gonna do very explicitly at an angle away from it. This distance. Oh no, I have to do distances again. No. Okay, I have the radius. Oh, it's okay. Just drawing that. I know what you're talking about, very funny. I like that image, it's a good image. Sometimes you just gotta reference images, you just gotta hope people know what you're talking about, because you sound absolutely insane if you don't, but like, you know, whatever. What's the angle of anything? 15 degrees. Okay, so this is 15 degrees. So this is 15 degrees. So, this is 15 degrees. What else have we got? 50, 90 minus 15? I don't know what that is. Let's see, 80, 75. Saying numbers for fun. Okay. That looks bad. That looks awful. You know that pi contains pi? No way. Wait, it's Pi Day today. Is that why we're talking about pi so much? I love Pi Day. G1 plus integral of the moments about G dt equals Hg2. It's Pi Day. Wait, did you not know? I did know because my Windows menu told me. But I'm gonna be real, I was a little worried about other things on my mind. Like, I had an art piece due today that I only just finished today. It was for a competition, and then the other thing I had to worry about was I had a lab final this morning. I forgot Pi Day, I know, I was sad about it. I was like, I bet I would have noted, because I journal every day. I would have seen it, I would have been like, whoa, it's Pi Day. That's 0. Okay, moments about G. We've got. I'm gonna have to do F equals MA. 3.141592653. This is an I test after I forget my digits of pi. Okay, so it's gonna be a positive. So we have n sine of 75. That's going like this. Right there. And so positive equals. This is like weirdly clean. Because this is not going to be here. MV2 is not going to be there. Uh-oh, wait a second. MV2 is not going to be there. That's not good. Okay, we can't do it about this point. I lied. We want to do it about C, I think. Because we'll have... Then we'll just have... Then we'll just have the weight. And we like the weight. With the math test, non-calculator says... What? That's crazy. They actually say that? Do they say that? Please tell me they don't say that. That's like the most massive waste of time I've ever heard. What? You're never gonna need to do that. You're never gonna need to do that. Yeah, the Mike Demon's been a lot better lately. I mean, I don't want to say that because I feel like I'm gonna jinx it, but like, you know, they've been a lot better. Oh shit, how do I do this? Oh wait, I can just do, oh, I can do direct perpendicular distance. I love everything. Oh, I love everything, guys. You don't even know. You don't even know. That's actually the most beautiful thing I've ever seen in the entire world. Alright, okay, that's a little bit of an exaggeration. It's just so nice when the direct perpendicular distance works out, because like for here, we had to like split it up and whatever. Oh wait, I actually have to do another one. Oh no, I don't, because it's MG. Yes! This is the funniest part of Damie streams. Well, that's sad, but I get it. You really, I have to fix it. I don't like exploding people's brains. Okay, let me think about this. So we want to say that attains the speed of that in 30 seconds. Times dt. I really need to start saying dt just to give myself that. Okay, so 30 seconds times mg times r cosine 75 minus m, I guess times 6, so like v2 times r. I just need to figure out omega 2, so and then divided by m. Omega 2 times m. Omega 2 is going to equal v squared r, but what does that mean, I guess? It's like, it's the system. What am I using for this? I've been using the R in terms of, well, so the R's that I've been using are for my moment arms, not for my system. Whereas the omega is just a general R. Or maybe I could just convert, yeah, because I need to say 6 divided by something. We don't know. I mean, I guess I could say that it's... Would it matter if I use the shaft radius? Let me think. Oh. I guess it should be the same. The magnitude should be the same on all points, right? Because it's on the same body. Yeah, that would make sense. Okay, never mind. I don't have to worry about it. I don't know why. That's funny. Oh. No, that's not true. The velocity is not the same on all points. If it's constant speed, it would be, but like if you think about like a sphere rolling, like it's not going to be that in a sphere. A circle, like a wheel, a disc rolling, not the same, so we can't do that. Math is like Lego. You can use different pieces to solve problems and build them all together and make something beautiful. Nah, because you always see everyone else build these big models and stuff, and you're like, that doesn't look too hard. Then you realize you can't make shit with your 3 Lego pieces. Even if you had more, you couldn't do anything worthwhile. Hey, that's not true. You forgot that, like, you can go to the Lego store and you can pick out whatever Legos you like. And, like, there might be some Lego kits that are, like, really hard and might take you, like, a while. But you can still try them as long as the Lego kits have, like, proper instructions, you know? And then once you, like, practice using the instructions, then you can, like, build your own Lego sets too, you know? Math is like Lego, I love it. Stares back at a half-built globe. Honestly, okay, like, being real though, if you want to do applied stuff, the math you need is not hard. Oh, meth, I see. Sorry, my astigmatism makes it so I can't read, like, circular letters very easily. Like, I mean, you can learn calculus without knowing, like, trigonometry, for example. It just depends on, like, what kind of stuff you're going to be able to use it for. Like, obviously, if you don't know trigonometry and you're trying to learn calculus, you're not going to be able to use it on trigonometry. That's okay, because if you just want to learn calculus... I could not learn calculus right now? Okay, ready? I'm going to teach you calculus. Okay. You know what a line is, right? A line's like this, and we can write it like this. So we want to find the slope of this line. How do we find the slope of this line? The slope of the line is like m, right? That's like, it's like y over x, right? Like the rise over the run. So we want a function that's going to be able to, we want like an operation that's going to be able to tell us the slope of this function, of any function. So in this case, it would be if we took, it's called taking a derivative. If we take the derivative of this, we want to get y equals m, right? And the same for like if we have a parabola. This is like a really good example, because it's like not easy to tell the slope, right? And that's like the general form equals ax squared plus bx plus c. So what we can say is that when we perform an operation on looking at a very small part of this parabola, it kind of looks like a line, right? So we can find the slope of that line. And the way that we do that is we're going to take a power and we're going to bring it down in front of it. So we're going to have 2a, and we're going to take -1 from that power. And this works here too. So with the b, we're going to take the 1, we're going to bring it down. We got b, and then we subtract 1 on here, and that's x to the 0th, and that's just equal 1. And this doesn't have any x's, so that's 0. There you go. Calculus. I just like seeing brain keeps on reading math with an E under your username. Can I get Subway Surfers? I did put up I did that and then I got distracted. I can't, that was lost on me. What did this guy just say? I don't know if I can say V. I can't say omega equals R. I can't say omega equals V over R. Man, this is depressing. I have to do something else. It's not the same. I don't know how to do the omega. How do I get the omega? Let me think. I know at the MV2 there. I know the omega of like wait, wouldn't it would just be V over R? What the hell am I talking about? Because it's an omega. The omega is the same for the whole shape. Okay, I'm wait, but that would mean, wait a second. That would mean that if I had any radius, let me just do this. I'm giving up. Okay, we're doing this. VA equals VO plus VA with respect to O. This always works. VA. We know VA. Wait, do we know VA? It's 0. Equals VO, which is 6 plus, this is omega R. Now omega R equals 6 divided by 1.5. Okay. Damie, we need to cook. It is omega R. I don't know why oh, what's 6 divided by 1.5? I don't know. 4. I didn't need to do that either. I can just do this. Okay. 30 times, how much did this weigh? I forgot. Uh-oh, I don't know how much it weighs. Oh, it doesn't matter. Going away. I love it when you cancel things out and you find out that the weight doesn't matter, because I feel like that's just such a cool thing to like have exist. You know, like, so many of these principles hold true for something that's any weight. And I feel like it's very equalizing in a strange way. I don't know why. It just kind of is beautiful to me. Uh, 6 divided by 1.5. There we go. Okay, here we go. Size. Now there's a point where I just turn my calculator, go over it. Okay. $91.5. Square root. I always forget that. A equals 9.566. What is this? Inches? Is this squared? Maybe. I don't know. I think it's just inches. I don't think it's squared. Let me see. Is that right? 2.79 feet. No. Okay, well, also, I don't think I changed anything to feet, and I think I need to change it to feet. Do I need to change it to feet? I don't think so. Okay, I don't know why that's, I don't know why that one, classic L. Okay, we've reached the point of regular, we've reached normalcy. Let's see if I can find it. I'm gonna check it out. Let me just see if this is posted though. It's like hidden away. It's like hidden away in like a dark little corner somewhere. 13? Is that this one? No, right? This is 14. Where's 13 and I just forgot. Oh no, this is... No, yeah, that's not this. Great, we're flying solo. I don't know why she wouldn't post it, because, like, we don't have to turn this one in. Okay, let's see, what could we have goofed? What could we have goofed? Maybe the coast 75. No, that's fine. I put the T in there. It should be in inches. Inches should be okay. The only thing maybe I goofed is the VA. I feel like that should also be okay. Because again, we're trying to find an omega there. We're not trying. We don't care about the. VA is 0 because it's the contact point. That's why it's special. Okay, well it's negative. Why is it negative? Oh, because the O should be negative. Did I forget any forces? Do we have friction? We probably have friction. Yep, rolls without sliding. That would do it, okay. How does that make our lives worse? Well, we're taking a moment about the contact points, so it actually doesn't really make our lives that much worse. We're kind of chilling. But, like, I mean, also not, you know? Because if that was the issue, then that's unfortunate because we can't find the issue. It is released from rest, and it does attain a speed in 30 seconds, so we got that. We don't really have to worry about the other stuff. Did I mess up I-bar? No, I-bar is k squared. Unless 92 is somehow 2 feet, which, you know, I guess I could just check. Nope, that's 7 feet, so that's not right. It has to be, like, way bigger, I guess. Like, way bigger. What would make it way bigger? First off, the M2V bar is... Oh, it's a positive moment. Well, first... Oh, wait, no, that's fine. It is a positive moment, so... Not good, yeah. Okay, I'll stare at it for a little bit longer. Let me think if there's any other forces we missed. I don't think so, because it's like, got a normal force. But we kind of just get rid of everything. We kind of just delete it. Which is great, but... And I don't have to worry about the perpendicular distance. Fine. Fine and good. Also kind of awesome that we can just find out the centroidal radius of gyration even though we don't know the like the radius of the outer flywheel. Isn't that kind of awesome? It's kind of cool. 6 inches per maybe a second. I don't think so, because that would be the velocity. Huh. I don't know, it's pretty off though. Oh well, I guess I can't check it. Well, let me see. I'm stuck. Sorry. Let me see if I have this in my little sneaky evil villain lair numbers. There's a chance because I think it's 17. 6.9. Wait, 0.69? Let's go. The funny haha number. Yes. Okay, what a goof. Let's see. Instantaneous center at C. Yep. V equals that. V equals RW. Okay, we got that. Good. We got the friction. I did that. And the I bar and that. We love that. What's about C? MGT. Okay. R sine beta. I don't know what their beta is. They don't define it. MGR over K squared plus RV. Or sorry, MR. It's so hard to read. MVR. VR. Maybe my cosine of. They use sine of 15, which is the same as cosine of whatever, and then minus 1. Wait, 32 times 30. That over, wait, 0.5? Wait, 6, no, that's 6 divided by 1.5 is 4. Wait, it's R times W. Wait, wait, whoa, wait, what? Wait. No, wait. R's... Wait, what? Wait. Did I like cancel out an R prematurely and then like... No, they factored out an R. Wait, I'm like like I set it up correctly. Then V over. No, it's V over R. Wait, how'd they factor out an R? Gamers, how did we do that? Oh, they just said. Wait. Oh no, they're just doing it. Did I like. Okay, 9 is not. 9 is not. 9 is not the same as 2 feet. What's happening? 30 times 32. Did I like get this right and I just put in the answer wrong? I mean, that would be great. 357. Did I not get that? Divided by 6 divided by 1.5. Square root. No, I still get 9 point whatever. Oh no. This is so strange because it's like really close to what I have. I'm like missing an R somehow. Did I just like Did I just not put the R's in? No, I put an R in there, 1.5. Did I not put a squared in somewhere? No. Not bad. Good morning, Davey. Good morning. How's it going? I'm like so confused. Wait, omega, but I put omega. Wait, what? What? Is this answer not working out? Do I just have to turn everything into... It's because of 32.2. Oh my god, guys, I got the right answer, but I used 32. I can't use feet and inches the same. Oh no. Oh no. Like, where am I going? Because I tried to use 32.2 and that should be like a million times bigger. Or I mean, I could just multiply by 12. Actually, that might be easier. Times 12. Smiles. Wait, so I just have to... No, I don't have to just multiply my answer by 12. Okay, I was scared. Yeah, 4,500 minus 6 times 1.5. And this divided by 6, divided by 6 times 1. Well, I mean, divided by 6, and then we did it. Okay, 33, and that divided by 12 is going to be 2.79. Okay. Oh, okay. That's beautiful, though. Like, that means that technically we've got 2 W's in a row. I'm going to take that as a W because me forgetting to multiply gravity by 12 is not a big enough mistake for me to care at all. We're winning. Me when I finally win right at the end. Yes. Sorry. I have to be evil. I have to be a little evil. As a treat. Oh, that's beautiful. I'm so pleased. I was gonna look at something. What was I gonna look at? We're only an hour in? Wait, this is great. Hey yo! Hey yo! Me when I get one problem. I don't know why these ones are so easy. Okay, I keep saying everything is easy. Maybe I'm just getting better at things and they seem easy. But to be fair, all of the setups have always seemed semi-easy to me. It's just that, like, the execution of them is neither here nor there, if you know what I mean. Okay. Oh, this is what I was talking about earlier. Like, if we have something that's pulling out, pulling on the bottom of something, and something that's pulling on the bottom of something. Don't worry about the other thing that I said. And it's not constrained, so it'll move and it'll rotate. Okay. 9-inch radius cylinder of weight blah blah is... No, it's so interesting to me because dynamics problems, like, so it looks like this, right? Like, this is what this thing looks like, but really what this is like, it's just like this. Like, it's just a line, and then, like, in space, this is just, like, sliding, and there's, like, certain forces on it, and you can think about it like that, and I think that's very funny to me for some reason. I don't know why. Like, everything in our world can just be turned into shapes and just floating in a plane with certain forces on them, and it's the exact same system as our system. And that's really, I feel like that's fun, you know? It's like, lose yourself, become a triangle for a little bit. If you're a triangle, right? Like, if you have a person, and you have a certain, you know, you have a certain moment of inertia about you, but if you were a triangle, and you had the same moment of inertia, just with it, like, times a constant, then you would be the same, is the thing. And that's very freeing. It's like Shib of Theseus, you know? It doesn't really matter. Like, all the forces would act on you the same way. It would feel the same. Mentally, I'm not sure how it would feel to be a triangle. But, like, you know, you could be this thing. And it's the exact same in the eyes of physics. It doesn't care. You could also probably have a different mass, and it wouldn't really matter in most cases. So you could just be really big. And that would also be fine. You know? kind of beautiful. There's not a lot of things that are like that. I don't know. Food for thought. What if you were a triangle and big? Great lessons we learned today on Damie VTuber. I'm gonna put that in the drawings. That goes in the real drawings. What even do I have up here? Oh, I have to make my. I do have to make my. Oh god. I forgot I put all these on this the same layer. I don't even know. Oh, it probably went to the bottom. That's scary. When did I draw that bird? That's scary. Me blowing up. Slug. Oh yeah, Goku. Not Goku. Just saying words. Okay. What do we want to do? I guess we need to draw some mass velocity diagrams, probably. We escaped them various ways because everything was 0. But this one we kind of have to can't really get away. These are 0. I don't really need to draw those. Little triangle and bird, big triangle and bird. This is just fascinating things about the ecosystem. So true. I would be a little I don't know. Being a little triangle would be really scary. Is the thing. I think I would also maybe try and be a diamond, like a rhombus, you know? If I could. Say 0. System is at rest. Sometimes I wonder if if my professor saw the way that I think about some of these things. What would she think? What would they think about that? Actually, is the thing. Oh, I need to think about the forces there before I figure out which way. Well, okay. For the longest time, I was like, what if it went this way and rolled backward? But then I thought about that, and I rolled a pencil in my hand, and I was like, that never happens. And I don't know, it's one of those things, this is kind of like when you try to draw a horse, and you don't think about how to draw a horse until you have to draw a horse, and you're like, yeah, that really wouldn't happen, would it? This is not going to rotate. Definitely not. So it's just going to have a velocity, I don't know, in some direction. Probably this direction. M, B, V, V, B, B. This one will be M, C, V, C. We'll put some axes. Y. There we go. We've ensnared them in our axes. Now we've got to put a bunch of stuff on here. So we've got a normal force. Okay, I'm actually gonna do this. I'm gonna put these in kind of really light. So our mg is not an impulsive force, and our n is not an impulsive force. Now if p was pulling up, then it would be an impulsive force. But neither one of these are creating really. Actually, wait a second on that. The n might be. I'm gonna draw them in like that. The mg certainly isn't an impulsive force. That is not with the. It's not like flying a gazillion feet up in the air and then changing its gravitational energy because it's in the atmosphere or something. So this is n. I'm just wondering because so we'll have. I think we can generalize an n here. I mean, unless we want to say this is n a or c, cb. NA, yes. And there's 2 wheels. And there's a P here. And that is certainly a P delta T. So we're neglecting the mass of the wheels of the carriage. So we're going to treat it as a big bar, of course. Because pretty much everything in this course is a bar or a line or a circle. Right, well, we're trying to find the velocity of the carriage. the carriage, oh, and center of the cylinder. Trying to find VC and VB. We got a lot of unknowns. Not really a fan of how many unknowns we have. Where can we take a moment to get rid of many of them? We took the moment about that contact point, like CB. We could get rid of most of them except for the normal forces on how much do we want to bet those normal forces are negligible? Maybe. I mean, they might not be negligible. But okay, well actually no, they're not okay. Let's do this. Let's start with a little stuff, with some little setup stuff. Some of the forces in Y, this is gonna be for C and this is B. Some of the forces in Y and C is gonna give us M-A-Y. No A-Y. I guess I kinda have to draw an acceleration diagram, huh? M-A-X. I don't know why I drew it there. Shouldn't draw it there. It's close enough. I didn't draw wheels on that. There we go. So we can say mg equals ncb. Then we can say in E, also not accelerating. So f m-a-y x m-a-y, right, 0. My handwriting gets worse. Okay. So mcg minus mcg minus m plus 2na 0, and so na. Okay, we know values for na, which is great. Wait, this creates a couple. We're chillin'. They're equally spaced around the centroid. That would be, oh my god, imagine. That would be evil. Imagine they're like, okay guys, this cart has a wheel here, and its center of mass is here. It is a wheel here, and it is a wheel here. Do this problem now. That would be evil. God, it wouldn't create a couple. Okay. But it actually didn't have to do any of this. Seeing those things is probably a good idea beforehand, but that's okay. I mean, I might as well leave it and say jaw drop, couple, oopsie, extra work. I mean, I'm pretty good, like, compared to some other folks, I think, about not doing too much extra work. I tend to kind of see the stuff a little bit better, but you know, I try to keep it efficient. Okay, think a moment about C. Nope, a moment about CB is what I meant. We're gonna get R times MCVC. So we'll call it 9. Wink 1 R. I got too excited. Okay, we have to do this for not about C. We have to do it for G. But I guess I should probably label. Okay, moments about A actually. I should probably call this A. But then I have to change the subscripts on literally everything. Saved? Yeah, I know. My mic goes bonkers. I'm sorry. And B. My least favorite thing about anything. I mean, it's worse for you. I can't hear it. Doesn't make it good, but I can't hear it. I don't know how my noise gate doesn't catch it. That's the weirdest thing. It's like a software thing, I guess. Or like bypasses my... It's some ghost. That's the problem. I gotta have an exorcism. There we go. Saved. Okay. Now we can do our little moments. It's gonna be system both. Alright, write that. System both. Okay, moments about A. So we're gonna have, like, I guess, NB times, I don't know, something, times D. It's a negative moment times D plus NB times D. Yeah. Equals. Now if we do a moment about that, we can get the it'd be a positive R times M V B that. And then uh-oh, wait, maybe I created the exact same issue. Wait, no, we get P. That's what I was doing. Times Hyper Omega VB VA over O. That's a VA. Fortunate. We need another equation then. Grr. That's not what I wanted to. That's not what I wanted to see. I bar VA over R equals 1/2 MR squared. VA over R cross equals 1/2 MRV. We can cross out an R, so we get P delta T equals MBV plus half 1/2 MAVA. Yeah, because we get rid of the R. So our other equation we can do, we can sum linear momentum to get MVBB. MVBBB. Wait. I can just directly get MBVB. And they ask for the velocity of the carriage first anyway. Man, I'm... Okay. It's fine. I mean, now that I have it, it's like I can just do it. Sum EI x plus some of the forces x dt equals sum P F x. E delta T equals MBVB. No way. Oh, crazy. I can't believe. So what is that? This P, they gave P, right? 2.5. O times 1.2. Divided by NB. 6 pounds. 6 pounds divided by 32.2. 2.5. 32 divided by 6 times 32.2, 16.1. Meters per second, feet per second, feet per second. And then MVVV. Okay, so P, so I'm just gonna do a little of this. So 2.5 times 1.2 minus 2.5. Uh-oh. Uh-oh, guys. Okay, we goofed something. We goofed something because it's PA equals. What did we goof? What did we goof? When we did a moment about. I mean, maybe we just keep. That's not a good moment for us. That might be a bad moment for us. But like, what? Maybe it doesn't move because, like, I don't know. That doesn't make any sense. Why would it not move? It would have to move probably. There's no way it would like cancel out perfectly. Also, if it were different, it wouldn't cancel out, right? Because like the math, it's always gonna be the same, and that doesn't make a lot of sense. Let's see. Maybe we don't use A as our moment point. Perchance. We could do, what could we do? What would be fun? I did a moment about, if I did the moment about AB, the contact point like I did before, I can get I bar omega. No, wait, I can't. But that's okay because I bar omega is that. But if I do that, it's just I bar omega equals 0. It's just that's not right either. What's wrong here? What am I missing? Oh, you know what I'm missing. You know what I'm missing. That's really not good actually because that ruins everything. A force that I didn't draw. Teehee. Teehee, I didn't draw force. I didn't draw force here. Uh-oh. Uh-oh, I didn't draw force there. Teehee. Okay, it's gonna go this way. It has to be on the other one too. No. My simple F. That's why it wasn't working out when I did that, because I was like, it can't just be the same value. Oh god, okay, wait, now we have to like do a lot of things differently. Oh no, we don't. Wait, FF equals PAX? Oh no. Oh, there's acceleration. It's not statics. Me when the dynamics moves? No way. That's crazy. That's crazy. Man, I really do not want to redo this whole last problem. Go back to it. It's not that we got it wrong, it's just that, oh boy, this looks fun. Oh boy, what is this? This is, fascinating. I kind of want to, okay, I think I want to do one more of these, and then I'm going to like sink my teeth into, I want to sink my teeth into like a little review problem that's a little different. Just so I can, like, not have to think about moments of inertia, possibly. I mean, I'll probably have to think about moments of inertia. I think the two things I need to focus on are kinematics. Sorry, not kinematics, polar kinematics. And, like, the difference between particle problems and rigid body problems. But I guess there's not really that much of a difference. It's just, like... Yeah. Just like knowing when they're particles or not. But I guess it's kind of obvious if, like, I mean, if they're rotating, then it's not a particle. I mean, I guess, you know, particles can rotate, but it just doesn't matter if they rotate. They're the same. Okay. A tube can slide freely on a rod, which in turn can rotate freely. Okay, so we got like a little fidgety thing. It's great. Initially, the assembly is rotating with an angular velocity of that, and it's held in position by a cord. The moment of inertia is that, and the centroidal moment. Okay, thanks. About the rod and bracket, about the vertical. Okay, the cord suddenly breaks. Great. Wait, it's a plastic impact. That's perfectly inelastic. Oh, it gets stuck? Fascinating. Okay. Well, let's get the first one. I was gonna say let's attack the first one, but that's a little violent. I just wanna. That's good. I like this one. He's like a funny little guy. Okay. Our first position is going to be this. Does it matter if I draw it in 3D? I think we can draw it in 3D. More of the question is, yeah, are they going to let me draw it in 3D, you know? I think so. I don't think it matters. It's got a cord here. It's spinning with I bar omega 1. Omega 1 equals 5, right? And then we have some thing, impulse, that happens. And we're gonna have a normal force. We're gonna have an acceleration that comes from the deuter. Which way is it spinning? It's spinning that way, so it's gonna be, guess the way would the normal force be going? It's kind of slamming against the back, so it would be going this way. The normal. Oh, I gotta have axes. Y. So this would be Z. This is probably a dumb idea to draw it in 3D, actually. But you know what? We're gonna stick with it. I don't know. It'll be cool to draw it in 3D. It'll be cool, they said. You know, you don't have to work with 3 coordinate axes, they said. After the tube is moved to end E, okay, so it moves all the way back here. So its center of gravity is gonna, you know, go out a certain point, and we're gonna have to change. We're gonna have to find the distance of the center of gravity, and then see what the, you know, I bar omega 2. And for this little dude, I guess it's not gonna have. I mean, it is gonna have a velocity on both of these. So this one, it's not gonna have a velocity. It's stuck at its center. This one, it's gonna have a velocity going this way. But I'm worried because I think it's going to be the rod and the bracket, so it's not going to be exactly in the center. And I really don't want to have to figure out a okay, no, about the tube. Thank God. They give it about the center. Okay. Ooh, I was worried. Wait, around the vertical axis. Oh, it's okay, it's okay, it's okay. Yes, they give us that. If we wrote, well, oh God, are we gonna have to? I think it's okay if we don't. We're gonna do parallel axis theorem. I don't want to have to do parallel axis theorem, like by hand. What I'm worried about is like, okay, if we have this tube, right? how it's rotating is like there's a point out here, and it's like rotating this way. So it's rotating about this axis here, and we're rotating around that, which is the same thing as rotating around this, which is the axis that they give us the I bar for. So we're chilling. Ooh, I got a little worried there. Okay. Yeah, we have some forces, and we also have like an MG, you know. What else do we have? I don't know, I think that's kind of it. Also, we have, we're not gonna have anything stopping it from moving in the other direction. We have, you know, an acceleration in the x direction, acceleration, there's no friction. It's going to be accelerating in the y direction because of the, not the y, the z direction because of the angular part of the motion, but not due to a force. The acceleration comes from the changing direction. Okay. Alright, I think we're ready to sum some stuff. Where do we want to sum about? I guess we want to sum, oh god. I guess we want to sum about, we want to sum about here, G, or C. Because that gets rid of all of our moments. And then we'll have, you know, some extra stuff, extra goodies over on the right. I think so. Yeah, that's nice. That's clean. I bar alpha, or I bar omega 1. I guess also, no. We don't have to say I bar 1 omega 1, because we're just saying like tube. Oh no, wait a second. Oh, the rod and bracket. Ooh, I got so scared. Okay, I thought it meant the tube and bracket. It's the rod and bracket. Okay, thank God. Okay, I bar omega rod bracket omega 1. I bar tube omega 1. I bar rod bracket omega 1. That makes my life so much easier. I really thought they gave us the... I was about to be like, dude, I do not want to parallel access this bit. Okay. 1 plus, I mean, I can, they have different I bars, so I can't really, well, I guess I can do this. Come back, there we go, I have to erase it like, omega 1 times I bar RE plus I bar tube plus 0. I mean, we can do that. Equals omega 2, and then we want to say I bar RB. Oops, that's The only way I know how to fix demon mic is by unplugging my mic and plugging it back in. You guys are so strong for being here during every demon mic. I'm so sorry. It's so scuffed. Oh, also it's gonna be V2, Omega 2 over R2, I think, so it's just gonna be Omega. Kinda funny. And then we know Omega 1. And we know all the I-bars. Why are these problems so much easier than any other problems? Maybe because they only have like... Well, it's a good thing it's the last topic because, you know, makes my life easier. Omega 2 over R2 times R2. I say this and then I'm gonna like get the problem wrong. Okay, 5 times. Now's the boring part. Now's the boring part. It's okay. Oh, pop this in here. There we go. What did I need to find? The angular velocity of the assembly after the tube is moved to NB. Cool, we got it. But we will need to find the energy lost in the impact, which is kind of an interest. Oh no, it's actually not that bad. We'll just have to do kinetic energy before, kinetic energy after. Which is actually kind of chillin' because we can just add some I-bars. There's no translational stuff. Oh, this is a beautiful this is like, why are these so serendipitous today? Maybe it's working out. Maybe it's working out, guys. Maybe we can escape. Oh, and Pikmin music, beautiful. 2.727, 2.787? Maybe? It's gonna be wrong. This is gonna be wrong. 2.54, that's really close. That's really close. Oh, we've just missed like one little thing, I bet. Is it gonna be that the thing is like this long? Is it? No, it looks like it's from the center. Wait, 500? Wait a second. Oh, no, no, yeah, it's... Wait, maybe it is telling us that it's 1.2125 long. I can't tell where it is on this picture. Like, it kind of looks like it's, you know, it kind of looks like it's saying the full, but it like doesn't. It looks like it's going from the center to that. 375. It's really close. Let's see, are we under or over? We're over, which means that I said it would change more than it should, I think. Stroking my beard contemplatively. It's so close to right. I can't check what the setup is. I mean, I could. Should we see? Let's see, 17.83. We'll check. Oh, Pikmin is just very quiet. I thought the music just stopped. That's fine. Okay, Pikmin, I love you, but you're too quiet. I need to find a better mix of the Pikmin soundtrack so it's not like an ant whispering in my ear. What was this? 8 something? 8-3. I'm so excited for the 1,000 Year Door remake to come out. I wish I could play it on stream. Okay, so see, they did it in a smart way. Oh, did I miss a squared somewhere? Oh, no. Wait. V equals omega R, not omega... not omega over R. Oh, I'm goofy. Times R. R would be, what was our R? I forgot. Our R would be 0.357. Yeah, that should bring that down a little bit, and then we should... Wait, wouldn't that make our value higher, though? I don't know. Let's see. Let's just walk around, find out, you know? Yeah, that's 10. Okay, I get 10 if I do that. Which is worse. Okay, what else did I do wrong? Did I do that wrong on the other side too? Wait, what was that? Whoa, okay, wait, that was the wrong thing I looked at. Oh, wait, I think... Wait, maybe... No, they're still using that stupid picture. RGA equals... Okay. Wait, 5 radians per second? Wait, yeah, it says 5 radians per second. What the heck are they talking about? RGA2... Okay, yeah, so they... Yeah, mine is twice as big because I put in the... Okay, because the diagram is awful. Okay, also, that's not an issue. That's not a me issue. I'd just like to say. Where even is that? Where did that come up? That, like, doesn't matter? Wait, where does that come up? Wait, am I, like, tripping? That doesn't matter, does it? What? I'm so confused. Wait, where do they put that? The 0.625. In the MABRGG. MABRGG squared. Their centroids are both at the point we're selling moments about, though, no? So AB, DC, omega 1, I did that. Yeah, MAB, V1, RG with respect to C1. Oh, it's just not in the center. Is that right? It's not in the center at the beginning? Wait, what? No, it's in the center. G, C, wait, they're showing it not in the center? Wait, what? Let point C be the intersection of axle C and rod DE. Not rod DE, and bracket DE. Let point G be the center of mass of tube AB. Okay, that is an awful picture. Okay, well, if we were doing it for this setup that I said, where the centroids are on top of each other, then this is right. Except it would be 10. Wait, would it be 10? Wait, what did I forget? Oh yeah, I messed up this. It would be high. If it was over there, it would be lower. Although I might have messed something else up, but you know what? I'm gonna bring it back to the more wrong one, because it doesn't... Well, I'll leave that. Nah, I'll leave it. You guys it's wrong, either way. I guess I just did the wrong problem. It's fine, it's okay if you do the wrong problem, you know? Copium. I really hope they don't have a diagram this bad any other time. If I can't look at a diagram and I can't figure out where the objects in the diagram are, it's not a particularly fun time. Anyway, okay, I think we can do one more. I'm gonna do a review one. I'm gonna pray it's a kinematics one, a polar kinematics one, just because I really like doing ones that are that. I guess I could find one that's polar kinematics. Me, please let it be polar kinematics. I could just pick one. I could just pick one that's polar kinematics. Silly me. I have any left. Mental velocity V. Ooh, that seems like. Ooh. Okay, let's do this one. This is a classic. I had to do this in my physics class all those years ago. This was actually a great lab. We put little airplanes on a string, and we flew them around and figured out their the tension forces and all that stuff. It was great. We like proved the T equals like the rho GH thing. It was a good lab. Okay, mass m is attached to a light cord and moves with tangential velocity v. Find the plane of motion. What the? By determining h. Oh, we just need to find h. Yeah. Find the plane of motion. Okay, you're going to say h and find the tension of the cord. Okay, so we got to do some free bodying, but let's free body first. Why not? Okay, how do we want to free body this? Axes are going to be very important. I'm kind of feeling like we do it this way, where this is H, and we're kind of looking at it like from here, this way. The V is going to be V is going to be like into the page. I don't think we want to do it the other way. Our tension would look like this, so okay, no, we're going to do it like this. So T, I don't need it to be that big. What are we compensating for? Okay. MG is gonna go down. I want axes like this, I think. Do I want axes like that? Sure. I don't think it matters too much. Any other forces? Nope. I mean, there's not lift, because it's got a tension that's keeping it up. Alright, and we need an MAD. So we are gonna have like two components here. So I drew it like that, this way. Well, this way it has... okay, it's a little goofy. There we go. It's gonna be a little weird because like its velocity is not in the direction of either of these. It's not the okay. I'm gonna draw it a little differently. We're gonna draw our axes kind of goofy. It's gonna be Z. This one. And into the page is gonna be This demon mic is killing me dead forever. Okay, this might be kind of hard to do. know MAZ equals 0. Well, I don't know about that one actually. Because then that means our... I mean, I guess MAZ equals sine... Boy, okay. It's gonna equal sine... Because of the way we chose the axes, that would have to equal... Oh, it doesn't equal 0. I lied. Okay, these... I think we should actually choose our axes in the other direction because of the way that this is moving. So I'm deleting these. Get out of here. We're gonna do this. We're gonna do these. And I know that's so weird for a tension problem, but like, you know. So MAX... MAY is going to equal 0. Wait, but that also gave me... Wait, no, what am I missing? What am I... No, okay. Oh, thank God, tension. Okay, well, yeah, the component, okay. The tension exists, thank God. Okay, sorry. Sum of the forces in Y equals MAY 0. Tension, beta. Cosine beta equals minus mg equals 0. T cosine beta. Oh, beautiful, okay. Equals mg. And, oh, well, there needs to be an L in here somewhere. L, oh, okay, we can get L in terms of H over R, I guess. And then we can use R as V dot, and you know, okay. Oh, you know. This is a weird little... It's kind of great. I mean, it's like not too bad. MAX, so T sine beta equals MAX. And so we need to find AX and AY. Or I guess we need to find AX. So A equals... Now this ball is a particle. Like, functionally this could have been a cable or something, also like zooming around. Well, I mean, I guess it has mass, so maybe not, but it is just a ball moving. It's like a particle moving around with mass. I need my... That's not it. That's it. I need these dudes. You can't see that. I need these dudes. My best friends. Okay, so R double dot minus R, ER. Okay, now the ER and stuff we'll have to kind of butts with, but R double dot minus R theta squared. R plus, what is it? It's like R dot, I don't know, I don't want to try and remember that. R theta dot, I already got it wrong. Plus 2 R dot theta dot. Okay, so ER is in terms of the polar motion that it's moving around. So that's going to be along T. Like this is ER. I'm going to just put both coordinate systems because why not? And then this is 90 degrees to it, so it's like this. That is our... I think so. You see E? Yeah. Oog. Alright. That's unfortunate, actually. I mean, I guess it's not that bad. We have to do some geometry, though. Wow, like, this is hurting my soul. Why did I not just do the other axes? not too late for me to change it. But I do need to make MAY and MAX equal like that. It's fine either way. It really doesn't matter. I mean, you have to do angles one way or another. But, you know. Okay, if that's beta, then this is beta. Okay, this makes my life easier. And this would be... Is that true? Because this line is this line. Sorry, this line is this line, and this is beta. So that would be beta, yeah. And then for the MAX, I'm not sure. I don't know which one is which. It doesn't, my drawing doesn't help me out. I want to say this one. Kind of looks 45 though. Not great for me. Which one would be beta? Let's see. Beta would be here. And this is 90, so this would be beta. Okay, good. What was the point of this? I already forgot. Why don't I just leave it? Why don't I leave it an X and then we'll figure it out. Okay, so this is gonna be 0. This is L. So A equals L times, so V equals, what do we want? I guess we want it in terms of V and M and stuff. So V theta dot equals V over R. So V squared over R squared. And R is actually R, it's not L, you know, or anything like that. Negative. Times ER plus, so I guess I'll just have to do some cosines for those. Theta double dot. Are we saying it's not accelerating? Are we saying it's accelerating? What do we think? Tangentially? I mean, it doesn't say constant tangential velocity. But I don't think it would have... What force would be causing it? That. I don't think we have a force that would cause that, because the T is gonna pull it to the center, but we're not changing that, so I don't think it's that, and this is also 0. This equals MAX. Wait a second. Oh no, MAX equals negative L, okay, negative L V squared over R squared. Cosine, made that up. Is it cosine? It's like, this is the component of this, so it would be sine. Sine of beta equals AX. Maybe. Possibly. What do I need? I need the height? How do I get the height? Bro, how do I get the height? L? Please don't make me put... Wouldn't it be really funny if it was my USB cord that was causing my mic to like fuck up? If I like plugged it in with my like shitty tablet one and it just like completely behaved, that would be really funny, wouldn't it? Let's see, L sine beta equals H. So H equals L over sine beta. Wait. L sine beta equals H. equals negative h. Whoa. Almost like they planned that to work or something. Wait. Okay, wait, I need it in terms of what? In terms of... T equals mg over cosine beta. So, okay, we've got all our ingredients. So, mg over cosine beta, sine beta, equals m times negative h v squared over r squared, which I guess is just omega, not omega squared. I lied. It's just nothing. No, it's omega squared. No, wait. Yes, omega squared. But we want that, so that's fine. M. Okay, we get rid of the m. Mass doesn't matter. Tan beta times r squared over v squared h. It's a negative value, which would that make sense? No, because it's going to be pointing... Well, I think maybe, because our r squared is going to be sort of a negative value in our setup. No, just r squared. What would be negative? Nothing. I think this is right, though. That feels like sort of right. I don't really know why you would want to... I don't really know why you would want... You would know the v and the r, but you wouldn't know the h. I feel like it'd make more sense to say v in terms of h and r. Which is, I think, what we did when we did this. Or, like, t. I mean, we can find t, right? So t is... Wait. T is mg over cosine beta, bro. I don't have to... What? What? Can I... Oh, maybe I can't use beta? I mean... T equals max over sine beta. We can do that. Only in physical constants, I guess, maybe? I don't know. That'd be m l v squared over r squared. Do they let me use L? You put Better Call Saul on? Yeah, I get DMCA'd instantly. I don't know if that's right either. It's probably close to right. That's like this whole channel. It's probably not close enough is good enough, but it's like 80% there, you know? You know what? With that, I think I'm going to call it today. That was a lot. We kind of did a lot. What did we do? We did like all of this. Oh, well, I messed up. But that's okay. That's like 1, 2, 3, 4, 5. Did I put this in there? That's the wrong place to put that. 6 in 2 hours is pretty good average, I would say. That's like very much above average. Oh god, looking at how many problems I've already done for my dynamics final is depressing me. 0 life. Okay, it's engineering. I have a reason. I really liked this one. This one was a cool problem. If it worked, if they drew a better picture, it'd be even cooler. Yeah, so I am gonna stream tomorrow. Which is kind of unprecedented, I know, 2 streams in a row. We're gonna do an EE speedrun. So I'm just gonna try and teach EE. The kind of caveat is like I'm gonna do some problems, but like not a lot of problems. It'll just kind of be like conceptualization stuff. So like for dynamics, I know I definitely won't be able to do any problems, but I'll probably be able to throw in a couple for EE. I don't know how well I can teach frequency response. Or no. I can do okay at teaching frequency response, I think. The one that I don't know if I can do is like the differential equations part of frequency response. But we should be good. This should be fun. Be hopefully helpful for I don't know, people who want to know a little bit about EE. We're like doing node voltage, and then we're gonna do mesh current. We're gonna do we have to do superposition. It's just like talking about stuff, and doing some problems. Yeah, that's really fun, and I'm gonna do that for all three of the subjects that I have. So there'll be one for dynamics too. Much less like math focused, much less doing stuff focused, much more just like podcasting about a subject. If you think about it like that. I'll probably have like examples and stuff. Dynamics is a lot of, actually, dynamics is gonna be hard to do a speed run of, but CE we're definitely gonna do a great speed run of it. EE we're gonna do probably an okay speed run of it. CE is a perfect class to speed run. CE 204. Yeah, I'll be back tomorrow. Then, not Saturday, but then I'll be back Sunday. And Monday? No. Yes. No. So, Friday, Sunday, Tuesday. That's what it is. That's the schedule. Me doing my CE speedrun the day of the exam. That's what that is. But what else am I gonna do? I got nothing to do that day. Might as well I'm gonna study anyway. Yeah, it's gonna be, my dynamic speedrun day is gonna be rough that Sunday because I'm taking a practice exam, which is 3 hours, and then I'm gonna stream for 2 hours. So that's like 5 hours of dynamics on lock. I probably won't do the exam, like, I mean, I'll try, but I don't want to do as much numbers stuff for the practice exam. Anyway, I'll see you guys then. Tomorrow. Crazy, right? That's wild. Thanks for hanging out. I know that it's like kind of maybe more boring. I don't know, maybe people just like it as background noise, but I'm excited for break when I can play some video games, because I'm gonna do that, I swear. You can have a good time. Have a more chill time. But I don't know. Dynamics is kind of my thing right now, so. Alright, well, I hope everybody has a good day, and I will see you guys tomorrow. Bye. Oh, where's my button? Here we go.